All right, we're good. All right. So we are going to take the quiz in a little bit. On page 22, there are 27 things, 27 facts that you need to know about F, F prime, and F double prime. Kevin, you need to know all 27 of these things. Your goal, working with your peers, using your notes right now if you need to, fill in as many of these things as you possibly can. This is not the quiz, this is the preparation for the quiz. We've got 3 minutes. This is like extra study time so that the quiz goes well. Use this time wisely. Page 22. Here that was the thing that you and I went for a walk on Friday. Get that done this weekend. Remember? Thank you very much. Much better than that. Okay, we're filling the table, right? Yeah. Now, this one doesn't it goes the opposite way. Like it switches direction. This one just keeps the graph going in the same direction. Alrighty, friends, here we go. These need to be quick like a bunny. Okay, if all goes well, everyone is going to tell me that if F is increasing, what do we know about F prime? Positive. You could also say above the x-axis. I like that. Goes really well. F is decreasing. What do we know? F prime is negative below the x-axis. F has a relative min. F prime. There is a change from positive to negative. So, of course, if you get that one, then you know about relative minimum. Change is negative to positive. F has a cusp point. F prime does not exist. Or F is not differentiable. But here's the thing. Cusp point, you're right. I don't want to get this up in my notes here. F is not differentiable. That's true, Jose. But you're telling me in this box about F prime. The derivative doesn't exist, but we would say that the function is not differentiable. Okay. Number 6, F has a horizontal tangent line. F prime is equal to 0. But if you have a vertical tangent line, then the derivative does not exist. You could also say vertical asymptote. You could say that it's going to be positive or negative infinity. Lots of things you can do. We'll look at the graph. If F has a saddle point, then the derivative is equal to 0, and the sign does not change. Sign does not change, right? A saddle point, something like that, or something like that. They each have a place where you have a horizontal tangent line, but in both cases, your function like increases, flattens out, increases. or decreases, flattens out, decreases. A graph with the horizontal asymptote, for example, e to the negative x, looks something like that. What happens with the derivative? What happens with those tangent lines? The slopes get closer to 0. If your graph has a vertical asymptote, then guess what? So does the derivative. And the second derivative, as soon as you get a vertical asymptote, it's with you forever. Okay, critical point means that the derivative is equal to 0 or does not exist. And then these last two we haven't talked about at all. So I would expect nobody's got this in their notes. The word is monotone. Monotone, just it does the same thing all the time. Imagine a teacher, if you could, who just has one tone all the time. It's not me. Whatever image you have in your head, it's not me. See, that's a different tone. You'll see you cry. We're not going to name them either. So if a function is monotone increasing, all that it does is increase. It never flattens out. It's not a saddle point. Monotone increasing would be like something like that. Or something like that. What it means is that the derivative is always greater than 0. Always greater than 0. Monotone decreasing, like e to the negative x, or you could decrease that way. Always less than 0. Now, the reason I want to make a big deal about this idea of monotone increasing and decreasing, in the past, if you watch a video from last year or the year before, my class, we would talk about increasing, and what we said was the derivative was greater than or equal to 0. The only difference is, do you include 0 as a point of increasing or decreasing? So for example, think about a parabola. Back in the day, I would have said that you're increasing. Is everybody okay? We're increasing over here? Yeah. Right? Over here? Mm-hmm. What about at the vertex? Back in the day, I would have said yes. There are some calculus teachers that say you're increasing at the vertex, and there are others that say you're not increasing at the vertex. I want us to be not increasing at the vertex kinds of people. So not greater than or equal to 0, just strictly greater than. My hope is that all of these, pretty straightforward, we get this under control. Okay, good. So let's look at the last one, and then we're going to take the quiz. F, F prime, F double prime. I would imagine some of you didn't have enough time to get there. So let's get this table complete. It'll be excellent study material. If F is concave up, a cup that would hold water? No. F prime is increasing. F prime, we're talking about the slopes of those tangent lines, right? Slope is negative, less negative, 0, positive, more positive, more positive. F prime is, what's happening there? Increasing. Increasing. And the second derivative? The derivative of an increasing function? Is not increasing. If this function's increasing, then the derivative has to be positive. When you draw a tangent line to a graph that is concave up, where is that tangent line?
Under.
It's under the curve, it is below the curve, so you could say below the graph. And if you are going to use that to estimate the value of the function, this is one of the things that we do a lot, what happens? You're going to get an underestimate. Now, we've had no conversation so far about secant lines in this. But, Jose, what do you remember about a secant line? That's not this one, sorry. What do you remember about secant lines? What's the difference between a tangent line?
Oh, it touches 2 points.
Tangent lines touch one time. A secant line would be something like this. I want to get this in your notes. I don't care too terribly much about secants, but there is a difference between tangent lines and secant lines. Tangent line touches once, secant line passes through twice. There's also a difference in location. The secant line, if I look between the 2 points, the secant line is always going to be above the curve. We're okay with that? Okay, so these are going to be above the curve. If your secant line is above the graph, and you use your secant line to estimate the value of the function, it's going to be an overestimate. Okay. So let's switch the thinking now to concave down. If your graph is concave down, this should be easy.
Decreasing.
F prime is decreasing. F double prime
Less than 0.
has to be less than 0. Those
Above
tangent
the
lines, draw a tangent line if you have to. It's going to be above the graph. Okay, above the graph, those estimates. Overestimate. Secant line passes through twice. Secant line, they're all going to be below. And so that's going to be an underestimate. Okay. And everybody is still 100% okay. The good news, mate, though, once we finish this off, there are no more. There are no more derivative rules for me to introduce you guys to. This is the complete list. Now, point of inflection. Who remembers what it means to be a point of inflection? What has to happen? Go back in your notes if you need to. I won't tell you. Point of inflection. It's like 1. What makes a point of inflection a point of inflection? Go back in your notes. You don't have to go back too far. Some people are looking for it on the ceiling. Naomi, what makes a point of inflection a point of inflection?
Where it changes between concave up and concave down?
Actually, that's not completely correct. What I heard you say is that the graph changes from concave up to concave down. That's partially true and partially not true. To be a point of inflection just means there's a change in your concavity. You said from concave up to concave down. Over here would be your point of inflection. The reason I'm saying that's not completely true, could you change, could your graph change from concave down to concave up? It's still a point of inflection. Okay? So point of inflection means changing concavity. Well, what happens in the derivative? If I've changed from being concave up to concave down, what happens with the derivative graph? F prime changes from increasing to decreasing, or the change is from decreasing to increasing. The derivative will change in this very particular way. What happens at the second derivative level? If you just change from concave down to concave up,
The opposite.
what do you mean the opposite?
Changing decrease to changing.
I disagree. It's not that F double prime changes from increasing to decreasing. It's a change from positive to negative, or it's a change from negative to positive. You could just say it's changing sign. That would be the same. Ashley, you okay? Stay with me. We got this. Everybody's good? All right, let's do it. Let's put it away. Here comes the quiz. There's 11 questions. Yes, you have 4 minutes. There is one question on here that if you get it wrong, you automatically fail the quiz. For real. I don't lie. For real. There is an automatic, you get it wrong, you fail the quiz, you'll know it when you see it. Ashley found it. 4 minutes. You get it wrong and die.
What do we do about how to spell your name?
Let's not cheat now. And anyone that spells it, L-I-N-K, not gonna do so well.
What's the question?
Oh, it's a good thing some of you are good looking. 3 minutes, 45 seconds left.
Wait, for real?
Yeah, for real. Thank you for your honesty. I just gave one of the solutions. Apparently I have really low expectations for one.
Pásame la luz. Verify from the line. This is 2016.
That just means when I made it. Everybody get a chance to see the grade sheet.
Yes.
About 10 more seconds. All right, friends, if you could please grab a marker, and there should be some in the containers. Okay, no problem. Okay, now, if you get something wrong, I can deal with your getting something wrong, but please give yourself the feedback. Meaning, fix it in a different color. Okay, here we go. Number one. If f prime changes from positive to negative at x equals c, that means that f has a relative maximum at x equals c. Now, other thing that I'll take, I don't like it as much. If f prime changes from positive to negative, last class somebody said, well, that means that f, what's that change going to be? If f prime changed from positive to negative, then f just changed from increasing to decreasing, saying a relative max would be better. Did everybody get relative max?
Yes.
At x equals c. Okay, if you didn't write that at x equals c for today only, it's still correct, but write it in. Okay, number two, if f has a cusp point at x equals c, then f prime does not exist at x equals c. If you said f is not differentiable, that's also true, but I really care about the derivative stuff here. Number 3, if f is increasing at x equals c, then you can write f prime of c is equal to 0, or you can say, I'm sorry, greater than 0, or f prime of x is greater than 0 at x equals c. I'll take either of those. Getting in the c is important though. All right, number 4, if f has a vertical asymptote, then f prime has a vertical asymptote at x equals c. Once you have a vertical asymptote, it's with you forever. Number 5, if f prime of c is less than 0, then f is decreasing at x equals c. Number 6, if f has a relative minimum, f prime makes a change from negative to positive at x equals c. Make sure you're being specific. Number 7, for f to have a saddle point, that means that the derivative is equal to 0 and it does not change sign. If all you have is derivatives equal to 0, that's not good enough. That would be a horizontal tangent line. You need the derivative to not change sign. Number 8, if f has a horizontal asymptote, then f prime of x will approach 0. We just talked about that one. Number 9, if f has a vertical tangent line, I'll take f prime does not exist. So you could say does not exist, or f prime has a vertical asymptote at x equals c. Same thing. Number 10, if f is differentiable, I wrote f prime of c exists. You could also write f prime exists at x equals c. And then be careful on this last one. This is the fail automatically if you get it wrong. For me, my favorite calculus teacher was Professor Scalise. My first semester Calc 3 professor in college. And I just got to tell you, anybody that has the opportunity to take Calculus 3 your first semester of college, stay away from that. Stay away from that. My first test, I got a C+, and I started crying in class, in front of all the peers. And I went up to Professor Scalise and I was like, are you going to call my parents? I actually was the kid that asked Professor Scalise, are you going to ask my parents? And he was like, no, you got the second highest grade in the class. I was like, oh, that's good. That's good to know. Roberto.
Fourth could be does not exist or does not exist.
I'll also take does not exist. Okay, so please count up for me. How many out of the 11 did you get correct? Hopefully a big number, like 11 out of 11. Tomorrow it's going to be harder because I'm going to hit you with all the f prime and f double prime relationships. Make sure you put it. How many you get right at the top? How many you get right at the top? 10 out of 11, 11 out of 11. How many of you guys get a perfect score? 11 out of 11. 10 out of 11. I can deal with 10 out of 11. Which one did we miss? Evelyn, which one did you miss? The last one? What? Oh, number 10. Not this one. You're too smart for that. Okay. Everybody good? Yep. We're going to do it again tomorrow. It is going to be harder tomorrow because it's going to be f prime and double prime. Carlos, can you go around and pick them up? Thanks. All right, page 23, Beto. Not to be confused with Beto. Jesus. Not right now. Okay. So Pedro, you've heard me say it a couple of times now. Wednesday, there is going to be a big, for real, 30-minute long kind of quiz. Not these shorties fill in the blank. The quiz on Wednesday is going to push your thinking. So, we're going to look at an example. We're going to go through this. We're going to get through as much of it as we can in the next 24 minutes. Jose, if you don't mind, can you read the introduction to this problem? This is what a question on Wednesday, the unit test, is going to look like and feel like. I want to make sure you're ready. Give it a whirl.
The graph of the derivative of f of x on the interval negative 8, 6 shown below for 0 is less than or equal to x less than or equal to 6. The graph of f prime of x is a semicircle whose equation is given by x minus 3 squared plus y squared equals 9, where y is greater than or equal to 0. Using this information, answer the questions if possible. Be sure to justify all of your answers.
Okay, one thing I want to point out right away is this idea of justifying your answers. When it comes to the free response, you have to back it up. It's kind of like the other day when we did the whole true because, false because. You have to tell me why these things are true. So a question like this, I want you to go through, just read over this one more time. What are the important things that they just told you in this problem? I want you to mark it up on this diagram. What are the things that you know that are going to be important? Pedro, what do you know? This is the derivative, right? This is f prime. And if you're Siraj Birch and he's going to live in calculus history forever, he would write f prime all over this. Because I'm going to ask you about another graph. I'm going to ask about f. I'm going to ask about f double prime. You've got to make sure you know what you're looking at. What else do we know? What else have they told you in the beginning of the problem? College Board, they always put stuff in the beginning and you forget about it later. Ashley, what else have they told you that's important? Anything else that you read where you're like, hey, this might be important?
X is less than 0 or equal to 0.
Well, wait.
Wait.
Are you reading this part over here?
Yeah.
Okay, 0 is less than or equal to x?
Yeah.
Less than or equal to?
6.
Okay, what about that?
Um,
From 0 to 6, what have they told you?
X is less than.
Keep reading here. The graph of f prime is a semicircle, so it's a half circle. And they gave you the equation. The equation is x minus 3 squared plus y squared equals 9, not 6. Also on the graph came out a little bit badly. Finish that off. It is supposed to pass through that point. Other things that they've told you about the graph is that this is the graph from -8. So here's x equals -8 to x equals positive 6. One of the rules of the road, and you've got to be really careful about this, do not talk about any part of the graph that you don't see. Don't talk about a part of the graph that you don't know. So when you talk about your answers down here, you have to stay between -8 and 6. Everybody okay? Don't tell me what you think is happening outside. Nobody cares what you think is happening outside. All right, let's do it. A, on what interval is the graph of f increasing? 15 seconds. Talk to somebody near you. F is increasing. How are you going to decide?
Where is it?
Okay, popular correct answer is 0 to 6. I heard 0 to 6 just about everywhere. But here's the thing, I need to know why. And here's what the justification. F is increasing means what? What does that tell me about F prime? It means that F prime is positive. I like to use this arrow. This arrow means, it means implies. F increasing implies that F prime is greater than 0. Wednesday, that gets you the first point. That's your justification. You know F prime is positive. Now I look at the graph, where is F prime positive? From 0 to 6. And I want to be really picky. 0 to 6, if you're going to use interval notation, parentheses or brackets here.
Brackets.
This makes a big difference. Look at what you wrote. You said F is increasing if F prime is positive. Positive, greater than 0. At x equals 0 is the graph equal to 0 or greater than 0? At x equals 0, that's this point right over here. Is the y value greater than 0 or equal to 0?
Equal.
It's equal.
So
I'm only going for where f prime is positive, so parentheses.
And then the other one.
And then the other one, parentheses. I have to be really picky about this. If you say f prime is positive, then you have to go with this. If you had one of those other teachers that says f increasing means f prime is greater than or equal to 0, and I'll accept both. But if you say f prime is greater than or equal to 0, then you look on the interval 0 to 6, and this time you have to use brackets. because your definition of increasing is different. You're saying greater than or equal to 0 versus saying greater than 0 here. Okay, with that said, you have 5 minutes. See what you can do in your groups, B through F. Use that summary sheet if you need to. Kelly, are you okay? You're tired. I know it's a Monday. It's hard for me to get both of my darling daughters out of bed this morning.
So whenever it's equal, huh? No, so whenever it's positive, B, what is the graph? A to
F is strictly difference. Only decrease. Not like up here where you might have a horizontal tangent line. So where is F decreasing? What has to be true about F prime? Right. This is where you want to get what graph is this? Not F1, this is F prime. I'm asking about F, which is the graph you use. Where is F decreasing? When F prime is negative, that's what happens to the negative 8. Because on this whole interval, F prime is lower than x. Okay?
She's saying versus. So F good job.
So F decreasing 0 implies F prime. I love it. Okay, why are you taking negative here? But I'm asking you about the graph of F. What does it take for F to have a horizontal tangent?
I want to do it.
I'm not sure. Go back to this table. Look at the table that I showed you. F has a horizontal tangent line. What do you know? F prime is equal to 0. Just thought of it. So where is F prime equal to 0? There. Not here, because number one, this is a custom. I'm asking for where does F have a horizontal tangent line that means F prime is equal to 0. Okay, which one are we working on? Okay, I don't like what I'm seeing there. If F is decreasing, F prime is negative, you'd get the first point. That's true. Where's F prime negative? Don't look at what you wrote. Where's F prime negative? Okay, first of all, you want to tell me that's true. Negative 8 to 0. That's the right thing to say. You wrote from 0 to 8. Oh, you like reverse and change the sign. Okay. Negative 8. Okay. You get the first point here because you know what's going on with the Pluto. Okay? Let's go. Points, please. Andrew, how are we doing here?
It says
The
left. Then what I moved over with this. It says X and then it's negative.
Okay, so where is it? You've already told me this and that first part, and then what you did was here, now I didn't know. Keep going, A through F. Hi there. How many right now? This is an absolute Then just go. Right, if F is concave up, What does that mean about F prime? F prime is increasing. When you look at this graph, where is F prime increasing?
I don't want to say hard, but I don't want to have right.
So if F is concave up, so I write F concave up means F prime is increasing. Already, you've opened the door, you get the first point. Now, tell me about this graph. Where is this graph increasing? -4 to 3.
I'm doing numbers.
And I would encourage you to so that we're not you're not increasing at -4. All right, friends, A through F from walking around going pretty well. I'm just going to show you what you need to have written so we can spend a little bit of time on the tough ones on the back. Yeah, those are these ones. Those are these ones.
I love it.
All right, part B. If you don't have this, please fix it. F decreasing means F prime is negative. That's the first point. That's your, like, I've made a connection. This is the justification. -8 to 0 with parentheses. How many guys would have earned both points? This should be like just about it. Ashley, hi, how you doing? Okay, part C. Find the x coordinate for horizontal tangent lines. Well, if F has a horizontal tangent line, then that means that the derivative is equal to 0. I have to see that. You have to connect me back to the derivative. Where's F prime equal to 0? At -8, at 0, and at 6. Okay. D. Carlos, you need to stop or you need to leave. It is a choice. D. Classify all the relative extrema. Do you have a max or do you have a min? Well, to be a max, F would have a relative max if F prime changed from positive to negative. Where does that happen? Where does, if F has a relative max, F prime changes from positive to negative. Look at the graph. Where does F prime change from positive to negative? Where does F prime, where does this graph change from positive to negative? Which means from being above the x-axis to being below the x-axis. That doesn't happen. So there is no relative max. At x equals 3, Jose, F prime would have a relative max. But I'm not asking you about F prime, I'm asking about F. Okay, now, F has a relative minimum at x equals 0. Why? Because that's where F prime makes a change from being below the x-axis to being above the x-axis, from being negative to positive. If you don't have this, please get it written down. Part E, in what interval is the graph of F concave up? Well, first of all, you've got to make that connection. For F to be concave up, F prime has to be increasing. So you look at the graph of F prime. Where is F prime increasing? F prime increases starting all the way down here at -4, all the way until you get to x equals 3. Is everybody doing mostly okay? Okay. Last one, part F. And what interval is the graph of F? Hey, you're back. Concave up and decreasing at the same time. I need both of those. So, just curious, can you guys draw on the air for me a graph that is concave up and decreasing at the same time? What does that look like in your head? The graph is concave up and at the same time decreasing. Imagine concave up. You guys all know what concave up looks like. And decreasing. Right? There's concave up. Where am I concave up and decreasing? That would be like this part here. So concave up and decreasing. So what's true about F prime? If F is concave up, F prime is increasing. If F is decreasing, F prime is negative. So where is F prime both of those things at the same time? Increasing and negative is from -4 to 0. Hi, Ashley. Okay. Now for the tough ones. Yeah.
Wouldn't that be concave down?
Nope. Concave up, you're thinking about a cup that holds water. Right, if I finished it, if I wasn't worried about the decreasing, it would look something like that. All right, friends, flipping over to the back. I'm going to keep this graph up here, and I'm going to do a little bit of side work over here. Part G, this is where length gets trickier. Where does F have a POI? What does it take for F to have a point of inflection? Look it up, please. What has to be true? I've got the graph of F prime. What has to be true for a point of inflection? Kevin, what has to be true? Hold on, I'm asking it. You're right. If F has a point of inflection, F changes concavity. But what you see is F prime. What has to happen on the graph, Beto?
Change from increasing to decreasing or decreasing to increasing.
F prime changes from increasing to decreasing, or F prime changes from decreasing to increasing. Where does F prime change from increasing to decreasing? F prime is the thing that you see in front of you. Nowhere. There is a place where F prime changes from increasing to decreasing. Right? This is the graph of F prime at x equals 3. I stop increasing, I start decreasing. So that means the original graph of F is going to have a point of inflection at x equals 3. Where does F prime change from decreasing to increasing? But from decreasing to increasing is going to happen at x equals -4. All right, let's keep going. H, what? POI is point of inflection. H, f of 2 is equal to 5. What I want is the equation of the tangent line. Have a quick conversation with somebody near you. What do you need? What's your approach? How do you get the equation of the tangent line at x equals 2? What are the things that you need? If you're going to write the equation of a tangent line, I heard it from a lot of groups, there's 2 things that you need. It's the same 2 things all the time. You want the equation of a line, you need a point, and you need the slope. Which one do we have already? We've got the point. They said f of 2 is equal to 5. So that's the point 2 comma 5. To get the slope, you need f prime of 2. That's what the derivative is. Derivative is slope of the tangent line. It's still the same. How am I going to figure out what f prime of 2 is? Okay, I've got the graph of the derivative. They gave me f prime. What's f prime of 2? What was that, Ben? So over here at 2, Jose is saying it's 2.7, it's 2.8. Here's the problem though. Is it 2.7? Is it 2.8? Would you bet your life on this?
We can
What could you do?
put it from the equation, the one they gave you.
Right, they gave me an equation way back in the beginning. What I need is the y value here. They told you that the equation was, what was this, x minus 3 squared plus y squared is equal to 9? So if that's true, go get me the y value. You know that x is equal to 2. Go get the y value. Hopefully you get an answer that is between 2.7 and 2.8. You know that x is 2. So 2 minus 3 squared plus y squared is going to be equal to 9. 2 minus 3 is -1. -1 squared, we get 1. Plus y squared is going to be 9. which means that y squared is going to be 8, which means that y is going to be plus or minus the square root of 8. All the good Algebra 2 students are going to write the plus or minus. So which one?
Positive.
Jose, why the positive?
Because it doesn't approach as 3, because whenever it's 3, it's decreasing. It's before 3.
Okay, I think you're losing sight of what we're after here. We're looking for the y value.
Yeah.
Why are you going to go, do you use the positive or do you use the negative? Look at the graph. Which one do you go with? You're going to have to go with the positive because you know that you're above the x-axis. So it's going to be y equals the square root of 8. Now, does that make sense? Okay, some people are, no, that doesn't make any sense to me. What did we know it had to be? What do we know that f prime of 2 had to be? It had to be close to what? 3. Where does square root of 8 live? Somewhere between 2 and 3. Really close to 3, the square root of 9 would be 3. So what we know is that f prime of 2 is the square root of 8. That's the slope. That's the point. I need the equation of the tangent line. Equation of the tangent line is always going to be, I like to write L of x for line. It's going to be the square root of 8 times x minus 2 plus 5. You would probably get 1 point for coming up with the slope, 1 point for writing the equation, and for the most part we'd say good enough at that point. Juan, how you doing? Okay, last one, we got 1 minute. On part I, use your answer from part H, estimate the value of f of 2.4. Get me the estimate for f of 2.4. Get the equation of the tangent line. What do we know about f of 2.4? It is going to be approximately what I get when I use square root of 8 times 2.4 minus 2 plus 5. I don't care what that number is, it's just an estimate. Whatever that number comes out to be, that's going to be your best guess. Tomorrow when we come back, we're going to finish off this part because we still have to figure out is this an overestimate or an underestimate. And we've got some work to do there. Tonight's homework, assignment 27. The first half is going to feel really good. It's going to feel a lot like what we were just doing. The second half is going to be a push. The expectation is you are doing both to the best of your abilities. I know I didn't have enough time to pick up the homework you guys did this weekend. I will be picking this up tomorrow. Get it done, get it done, get it done. Assignment 27 is what we're doing tonight. I think it's assignment 26. Yeah. Why are you thinking that? Is that what would happen?